Let's look at a couple of other examples. We're going to have log of x plus 15 is equal to 2 minus the log of x. So here I have logs on both sides, but I also have a constant. What I need to do in these cases is I need to get all my logs on one side and get my constant on the other side. So in this case, I'm going to add the log of x to both sides. Now, when I do this, do not combine your arguments. These are two separate logs. I can't combine my arguments. It's going to look like log of an x plus 15 plus the log of x. We will be able to combine our arguments, but not the way you would think in getting like a 2x plus 15 or anything like that. Because where we add logs, remember we have that rule or property in which where we combine logs, we multiply our arguments. And so we would get log of an x times x plus 15 is equal to 2. And so in this case, what's going to happen is now we have a log equal to a constant. We need to look at what our base is. Well, we're not given a base. So we have to realize that this is the understood base of 10. So we're going to do 10 raised to the second power is equal to x times x plus 15. So 10 squared is 100. And then I'm going to distribute and get x squared plus 15x. I have an x squared, so I need to set this equal to 0. So I'll subtract my 100. I will get x squared plus 15x minus 100. Now I need to factor. I need to come up with two numbers that will multiply to give me 100, or I'm sorry, a negative 100, and add to give me a positive 15. And that would be a positive 20 and a negative 5. I will set each of those equal to 0. So I will get that x is equal to a negative 20. And x is equal to a positive 5. When I check in my arguments, remember my arguments are x plus 15 and an x. Well, putting in a negative 20 in for this x, that doesn't work. Putting in a 5 here works. Putting in a 5 here, 5 plus 15 gives me a positive 20. So x equaling 5 is my solution. Let's look at another example. And let's look at if we have log base 4 of an x squared minus 9 minus 3 is equal to a log base 4 of an x plus 3. Okay. So in this case, we can do a couple of different things. I need to get my logs on the same side. So I'm going to subtract my log base 4 of x squared minus 9. from both sides, I will get a negative 3 is equal to log base 4 of x plus 3 minus log base 4 of an x squared minus 9. And then whenever I try to combine these two, this is a subtraction, so that's going to mean that I'm dividing, and I will get x plus 3 divided by an x squared minus 9 is equal to a negative 3. I'm going to change this into exponential. So I'm going to get 4 raised to the negative 3 is equal to an x plus 3 divided by an x squared minus 9. Now, if you think about 4 to the negative 3, that is the same thing as 1 over 4 to the third. And then I have an x plus 3 is equal to an x squared minus 9. So 4 to the third is going to be 64, so I have 1 over 64 is equal to x plus 3 times an x squared minus 9. And basically I have a proportion here. I can cross multiply, or if you look at this x squared minus 9, x squared minus 9 is the same thing as an x minus 3 times an x plus 3, if I factor this right here. And so then I would get 1 over 64 is equal to an x plus 3 over an x minus 3 times an x plus 3. And the reason why I want to look at it this way is because notice my x plus 3's will now cancel out. And I will get 1 over 64 is equal to a 1 over x minus 3. If I cross multiply now, I basically get x minus 3 is equal to 64. And then I add my 3. So I get x is equal to 67. You would have gotten the same thing if you had cross multiplied here. It would have just taken you a lot longer. And there's no reason to. So if you have something like this, see if it'll divide out if you can. And then whenever you take the 67 up here, 67 plus 3 is 70. 67 squared minus a little bitty 9 is definitely going to be a positive number. Again, make sure that you're checking those solutions in your arguments.